The report Propagation of Elastic Waves in Cross-Sectionally Heterogeneous Rods is presented by Anastasias Deshits and Valeris Deshits. The physics of collisions related to wave propagation in elastic rods has been investigated for more than a century. It is known that the propagation speed of C waves in thin rods is equal to, where E is Young's modulus of elasticity, B is the density of the material. Problem: can this formula be used if the rods will be, for example, stepped with the variable step length, or rods with asymmetric holes of different depths? The speed of elastic waves was measured by the propagation time of the elastic wave in rods made of aluminum, iron and copper. A piezo sensor connected to a digital oscilloscope was used to register pressure fluctuations at the end of the rod. Thus, the average wave speed can be found using the equation, where Tk is the time between two pressure pulses at the end of the rod. You can see a photo of the research installation in Figure 2, where 1 is a metal ball, 2 is a guide tube, 3 is a rod, and 4 is a piezo sensor. The results of measurements of the speed of elastic waves are shown in the graphs of Figure 3 for steel, aluminum and brass. The method of measuring the speed of elastic waves using a guide tube turned out to be the most accurate, with an error of up to 1%. The results of oscillographic measurements of the speed of elastic waves in an iron rod with a hole of different depths are shown in Figure 4. Experiments proved that the propagation speed of an elastic wave in a rod of finite length depends on the shape of its side and inner surface. For stepped rods, there are two characteristic areas in which the velocity differs from the wave velocity in one-dimensional rod by around 20%. The extreme speed of the wave reaches when the length of the step is about 0.25 and 0.75 of the length of the rod. For steel, the maximum speed was 5,958 meters per second, aluminum 6,098 meters per second, brass 4,065 meters per second. The minimum speed was 4,000 meters per second for steel, 4,098 meters per second for aluminum, and 2,747 meters per second for brass. For rods with asymmetric hole, there are also two characteristic areas, in which the velocity differs from the value of the wave velocity in one-dimensional rod by around 3%. The extreme speed of the wave reaches when the depth of hole is about 0.25 and 0.75 of the length of the rod. For iron, the maximum speed was 5,376 meters per second. The minimum speed was 5,025 meters per second. The results of these works confirmed the influence of the shape of the variable cross-section of the rod on the speed of propagation of the elastic wave. Thank you for your attention.